For this next bit, I want to show you how to graph a quadratic equation, or graph a quadratic function. Now, one of the ways you could graph a quadratic is you could just simply plug in a bunch of values and eventually you get the picture of what it looks like. So for instance, if f of x is equal to x squared, I can plug in a bunch of x values and find the corresponding y values, where this is my y, and see what we end up getting. So like for instance, if x is equal to -3 or -2 or -1, 0, 1, 2, or 3, right? -3 squares to 9, -2 squares to 4, -1 squares to 1, 0 squares to 0, 1 squares to 1, 2 squares to 4, and 3 squares to 9. So what this tells me is that it tells me if x is equal to -3, then y is equal to 9. And if x is equal to -2, then y is equal to 4, and so on and so forth. So this gives me points that I can plot. -3, 9, -2, 4, -1, 1, 0, 0. And then I could actually plot these on axes. So -3 gives me 9, -2 gives me 4, -1 gives me 1, 0 gives me 0, 1 gives me 1, 2 gives me 4, and 3 gives me 9. And then when I connect the dots, I end up getting something like this. So for this quadratic, I've already graphed it. This is what you could end up doing. The problem is, sometimes the quadratic might look like this. Sometimes the quadratic might look like this. Sometimes the quadratic might look like this. You don't really know where to kind of look for that real signature piece of a quadratic, which is typically that turning point, which we call the vertex. And if you just plug in a random x values, how are you going to know if you're picking the right x values to actually show what the quadratic looks like? For example, had I done this quadratic by picking out -3, -2, -1, I would have had something way, way up there. Or I might end up like picking the wrong values and I might get something that looks like this. Now that doesn't look like a quadratic, it almost looks like a line, but it could be part of a quadratic if the quadratic curves right there. So then the question becomes, what are the important features and how do you find those important features when you're graphing a quadratic function? So the important features are the vertex, they're the x-intercept, they're the y-intercept, and whether it opens up or down. If we know all of these things, then we can actually figure out, what it's supposed to, how to actually figure this out. So, first of all, for the x-intercept, when it crosses the x-axis, that means that y is equal to 0. So for that one, we're just going to set y equal to 0 and solve. And whatever x's we find, it's typically usually 2. Sometimes there's none. Those are the x-intercepts. For the y-intercept, x is equal to 0. We're just going to set x equal to 0 and solve for y. There's always a y-intercept and we'll find it. Opens up or down. If the first coefficient is positive, it opens up. If the first coefficient is negative, it opens down. So what's the difficult part? The difficult part is the vertex. Here's the way the vertex works. Every quadratic can be written like this. F of x is equal to a times the quantity x minus h squared plus k. And in this case, the vertex is h comma k. This might look a little bit familiar. This comes from completing the square. If we complete the square for a quadratic function, we're given the vertex. And so we can actually use that to find the vertex. So I want to show you an example of graphing a quadratic function. So let's say f of x is equal to 4x squared plus 8x plus 9. So the most difficult part is certainly finding the vertex. So I'm going to leave that for a second and go straight to the other stuff. The y-intercept, that's probably the nicest. Well, actually, it's probably the second nicest because actually for this one, 4 is greater than 0, so it opens up. It looks like this. Now the y-intercept, plug in x equal to 0, so you get 4 times 0 squared plus 8 times 0 plus 9, which is equal to 9. So the y-intercept is 0, 9. The x-intercept. 0 is equal to 4x squared plus 8x plus 9. This is a quadratic equation. This is part of the reason we've been doing quadratic equations. So you solve it out and you get x is equal to negative 8 plus or minus the square root of 8 squared minus 4 times a times c all over 2a. So x is equal to negative 8 plus or minus the square root of 64 minus 4 times 4 is 16 times 9 is, well, let's see here, 16 times 9 is equal to 144. Wait, this is where the discriminant becomes kind of important. This is negative. It's negative, so the only solutions we have are two complex solutions. Complex solutions can't be graphed, so there are no x-intercepts. So that takes us to the vertex. This actually tells me something. This tells me that the vertex is above the x-axis. Because if it opens up and it's above the x-axis, then it's not going to cross over the x-axis. Which makes sense. It doesn't have any x-intercepts. So for the vertex, what I'm going to do is I'm going to take that 4x squared plus 8x plus 9, and I'm going to complete the square. So this goes back to completing the square. So I'm just going to run through it. Here's an example of completing the square again. So first I'm going to factor out the 4 out of the first two pieces. So I get 4x squared plus 2x plus 9. Then I'm going to complete the square inside here. So I get 4 times the quantity x squared plus 2x plus 1. And that comes from taking half of the 2 and squaring it. And 1 squared is 1. So I'm going to add 1. Now, because I added 1, technically I added 4. And if I add 4, the only way to undo that is to then subtract 4 as well. And I still have the plus 9. So this becomes 4 times x plus 1 squared minus 4 plus 9 is plus 5. So if we look at the form for the vertex, then in our case we have 4 times x minus negative 1, if I had a minus something, squared plus 5. So h is equal to negative 1, k is equal to 5. And so the vertex is at negative 1, 5. Alright, so this gives me some important points. So I've got negative 1, 5. I've got 0, 9. And I've got opens up. So I'm going to rewrite the function. It was f of x is equal to 4x squared plus 8x plus 9. And if I go to graph it right now, I really actually don't have enough information. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's this point. 1, 1, 2, 3, 4, 5. That's this point. So that's the vertex, and it opens up. Now, odds are it looks like this. But how quickly does it jump up? One of the things I could do then is, since I know the vertex, I could find some other points around it just to plug in. So I'm going to try out negative 2. What is f of negative 2? Negative 2 squared is 4. 5 times 4 is 16. Negative 2 times 8 is negative 16. So it's equal to 9. So negative 2, 9. Now I've got another point, so I can start to see that the parabola looks like this. And so that's the graph of that quadratic. And you can pretty much play this game where you're trying to figure out what the quadratic is using, you're trying to figure out what the graph looks like using all the information from the vertex and the x-intercepts and the y-intercept and so on and so forth. So let's just find another one real quick. So suppose that I have f of x equals, let's say, x squared, let's say minus 6x plus 8. So here, opens up, f of 0 is equal to 8. When 0 is equal to x squared minus 6x plus 8, I get x minus 2 times x minus 4 So x is equal to 2, x is equal to 4. So far I've got the points 0, 8 for the y-intercept. I've got 2, 0 for an x-intercept. I've got 4, 0 for an x-intercept. I've got it opens up. For the vertex, I complete the square. So I got x squared minus 6x. I'm factoring out a 1. So I can even put it there if I want to. And then half of the negative 6 over 2 is negative 3 squared is 9. So I'm going to add 9, so this is equal to 1 times x squared minus 6x plus 9. Subtract the 9 plus 8. So I get 1 times x minus 3 squared minus 1. And so this tells me that h is equal to 3, k is equal to negative 1. 3, negative 1 is my vertex. And now when I go to graph it, in this case I probably have enough points to go with. I could always plot another point if I wanted to, but let's just double check. I have 1, 2, 3, 4, 5, 6, 7, 8. That's the y-intercept. 1, 2, that's the x-intercept. 1, 2, 4, 0 is an x-intercept. 3, negative 1, that's the vertex. Maybe I'll just plot in real quick what is 5, f of 5, just so we can draw it up here. And f of 5 is equal to 25 minus 30 plus 8, which is equal to negative 5 plus 8 is equal to 3. So that's this point right there, and if I connect the dots, I get something that looks like that. So we've done x-intercepts using the quadratic equation. Y-intercepts we've done before, it's just plugging in 0 for x. Opening up or down, that's just simply determining whether or not a number is positive or negative. And finding the vertex, that comes from completing the square, which we've also done. So putting it all together to draw these quadratic functions is pretty much what today's lesson, what we're hoping to be able to do now today.